Lecture 1, Segment 3, Hand Sketching from Isometric to Orthographic Views. Well, this is one of the few lectures where you actually have to put up and look at me briefly. Thankfully, we'll avoid that for too many of them. I think more of you than to force you to look at me all the time. But at least on these hand sketching ones, we have the ability to do that. So we do that so you can see that I'm a live, real, honest-to-goodness person and not just this disembodied voice that appears on most of your segments. So what I'd like to do is take a moment and do a little hand sketching. And the reason I like to do that is because hand sketching goes hand in hand with solid modeling. If you're good at hand sketching, you'll be good at solid modeling and vice versa. And I want you to be able to do a little bit of hand sketching just to get the feel for it, to be able to flip between 2 dimensions and 3 dimensions. A basic fundamental skill required of any engineer, that ability to manipulate 3D space in your head. And this is a great way to build that kind of skill. So let's take a nice simple part this week. Let's not do anything too ridiculous. I won't have any curves or anything nasty. We'll save those for next week. But what we'll do is we'll look at this simple little part here and see, can we draw it in its 3 principal positive orthographic views? What do I mean by that? Let's have a little quick review from last lecture. If we were to draw a glass box around our solid and unfold that box properly, we would come up with a top view, a front view, a right view. Those are our 3 positive views. And then we have our negative ones as well, the bottom, the left, and the rear. And we said something kind of interesting about those is that they are equidistant from each other. Each view is the same distance from a neighboring view. I know I didn't draw it that way here, but it's close. And each view in this case would be A apart, that distance A, whatever that happens to be. That's arbitrary. We get to choose that. That's all up to us. And the point here is that we always show adjacent views, so we don't have to label views. Just by the arrangement of views on the piece of paper, we know what views we're looking at. So if we only see those 3, we know that we must be looking at top, front, right. And if we only see 2 views stacked on top of each other, well, it's got to be top, front, or possibly front, bottom. You know, there might be a little ambiguity, but not much. And that is the whole point here, is that we don't want any ambiguity. We tend to want to make things nice and crystal clear. And normally, when in doubt, always assume positive views. So that's how you can get around that issue. All right, how do we get here from this? Well, the first thing we need to do is we need to get ourselves some decent paper to sketch on. There it is. This is some orthographic sketching paper. I've included some in your collection of data. You'll find a PDF page called Ortho that has this orthographic paper, and you can fill it out. And we should really start when we fill it out by filling in the title blocks. I'm going to do it on this lecture. I won't go into the details for the others, but let me just zoom in for a moment and show you what I mean here. We should give this thing a title. This is just good engineering practice, that's all. I'm just showing my age here by doing this with you. But again, you might as well. It's a nice way to practice your lettering, get your hand going well, good hand-eye coordination. There's nothing wrong with that, nothing to be ashamed of. I have some of the sloppiest handwriting on the face of the earth, and yet I can do some decent lettering when I take my time and do so. And it's nice to know that they were finally able to discipline me to make that occur. I'm filling out things like the sheet number. This is sheet 1 of 1. We're only going to have 1 sheet. The scale, I'm going to draw it 1 to 1. I happen to know that's the scale I want. You may wait to fill that in until you decide, well, do I want to use 2 to 1? You know, 2 bricks for every 1 on the drawing I'm coming from. You may have to make that decision. I can put in the date and the place for your section number. And then over here on the far left, I left a block. You know, perhaps you could fill that in with your school ID or logo or whatever would be appropriate there, and I leave that to you. So I filled in my title blocks, and now I think I'm ready to begin to create my orthographic views. Here's my solid. I've already drawn on it for you a triad, X, Y, and Z. This is the isometric coordinate system that we choose to use in this course because it's one used by most solid modelers. And it's a very popular one. Again, remember you may see different coordinate systems in some of your engineering courses elsewhere because they don't always follow this convention. Many of them use Z as the vertical axis, and XY is kind of the ground plane, and that's very common in things like fluid mechanics and heat transfer and many of those other courses that I remember taking back in the dim, distant ages. But in solid modeling, we use this axis system. And why do we do that? Because it gives us the XY view as our front view. And that's the only reason. All right. What I do is I like to count the overall size. So if I go along here and I count along the x-axis, I'll get 10, I'll get 7 for the overall height. And then for the overall width, I got to be careful, because if I use the right here, I only see 6. But it's longer than that. There's 2 extra out here. So you got to make sure you use one of the longest ones. And that's 8. So I need 10 by 7 by 8. Now how do we translate that onto the piece of paper? Well, and I'm going to change pen colors. And I'm going to start by drawing a little block down here on the corner. Just a little corner here. And you see what I'm going to do is I'm going to say that's my starting point. And I know that this is where I want my front view, because I want front here, right here, top up here. And I know that that's what? 10 by 7. So let's put that in. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And close it off. And if I really wanted to, see, I can. I would not do this on something I turn in, but just to show you, I'll just draw my little coordinate system here, x, y, so you can see where that is. Now I want to go some number of spaces over and draw my right view, which is going to be my YZ view. And I know that it's going to be 8. And since I started 2 over here, maybe I'll start 2 in here and go 1, 2, 3, 4, 5, 6, 7, 8. Because this is now the Z-axis on this view, and it's still Y here. Notice that the front and the right share a common axis. That's something we talked about last time. And you'll note that that just happens to work out to 4 spaces between the 2 views. So for my top view, I'm going to go up 4. Why 4? Because I have 4 here. I'm going to keep equal space between each of the views. And again, this is my x-axis. So this axis here, the vertical axis, is now a z-axis, and there's 8. So 1, 2, 3, 4, 5, 6, 7, 8. Got it right. And just for completeness, zx. So front, right, top. And there they are. Now, when you draw, I would only draw these little corners. I would not draw the triads, and I would not label the views. That is not proper engineering drawing, but again, I'm just trying to show you here because a lot of you have never done this before. Well, let's start working on this front face, shall we? Let's just draw this front face. So we're coming in from z equals positive infinity, and we run along the axis until we slam into a piece of solid, and here it is. And what does that piece of solid look like? Well, it looks like this face right here. And we can see along the back edge here, at x equals 0, it runs a total of y equals 7. So I can sketch that. Likewise, at y equals 0, it runs the entire length. Now, you know, a neat trick you can use, you can always reorient your paper like I'm doing here, but here's a neat trick that I like to do. I like to draw my start and end points on these longer lines. And if I don't have a ruler, I just take my pen and I go back and forth a couple, 3 times, and then pull the line across. And that makes it go a little straighter. That's an old drafting trick, and believe me, I'm old enough to know old drafting tricks. So that might be one that you might like to try for yourself. Now let's just follow it through. We see we go up 3 and then over 3. So I'll go up 3 in y, over. And then over here I have 4 over. And then that just leaves me this angled piece here like that. And I've drawn now that front face. And that's very much what it looks like in 2D projection. However, I'm missing a couple things because it turns out I have X-ray vision with orthographic views. Remember we talked about that last time as well. So I need to put in lines of the faces I would also see. So if I kept progressing through this solid, the next face I'd run into is the rectangular face here. You can see it here very nicely, the one here. You can see that it comes over to the end here, and it goes in 3, down 1. And let me first draw it, and then I'll talk about it. Hidden lines are indicated with dashed lines, like that. And that says that that's hidden from this main view here, but it's in there. Notice that hidden lines begin and touch solid edges. Solid edges take precedence. This line is shared over here, right? This line and this line, but this one takes precedence, so we draw it as solid. So solid always takes precedence over dashed. But the dashed then, notice it starts and ends on a solid. Notice that the corner here is drawn with the two pieces connecting. And that's important because that tells us that that's where this interior feature ends. And then we dash in between. It should be relatively evenly spaced. And if we kept going, we'd run into this next surface here. Well, we already drew that. It's identical, right? Because they're both symmetric about the center line of that cut. And then finally we come to the end surface here. And that will just simply be shown like that as an additional hidden line there to indicate that that back surface is there. And that again is this surface back here that we can't see. It's that one back here. Remember, I give you the solid, so feel free to go in and pull this up and spin it around till you convince yourself that that's right, that that's what we need to be looking at. Well, let's look at the right view now. That might help us out and see this a little bit. And the right view is fairly straightforward. We go up 3, and we go over 6, and then up 3, and then over 2, down 1, like that. And then this surface just appears as solid line like that. This back surface is nothing more than another rectangle. And then this slanted surface all the way to the top just appears to us like this. Remember, we only have 2D vision, so we don't see the angle here. We see it here. We see the projection. We see what? We see this face of the projection here. That's all we're seeing. Likewise, on the top view, this is very simple. We come down. We first hit this surface here. Let's sketch that in. And then we come down and we see the projection of the angled surface. And then we see, and goodness, my sketching is getting sloppy. A little thicker than it should be. And that's what we see. And notice that there are no hidden lines in the other two views. But before we finish on this, and I realize this is a little bit of a long segment, let me show you something. Let me pick another color. Let me go to green here and just show you a nice way to check this. Notice that between any two adjacent views, I can sketch lines of projection. And do you see how everything lines up? Isn't that nice? Do you notice how everything's lining up? Between the top and the right view, sketch a 45, and again, everything will line up. And notice it does. So you have this neat little check to make sure that you haven't missed simply by doing these checks. Let me zoom back out. Let me come back in and wrap this up. So what we did is we took this simple solid and we drew it in its 3 positive principal views. What you're going to turn in is the stuff in black. You're not going to draw these little dashed lines or this 45-degree line or the orange axes or the labels. You're just going to draw the 3 views. You are going to use hidden lines where appropriate, and you are going to, you can use this checking methodology just to ensure yourself that you have everything lined up. And remember, this only works with this 45-degree angle if you use the glass box projection. So use glass box, check your work, use your hidden edges, remember to connect them to the solid edges, and solid edges take precedence. And you've gone from 3 dimensions into 2 dimensions, and you've started to make an engineering drawing. And once we add annotations, which we'll do on the computer, you'll be on your way. So you've really made a nice start. When you're ready, come on back, and we'll start taking a look at how we start doing all this